Hi, everyone. Thank you for coming once again to our virtual Tap Talks. So this week has been World Space Week, and so in celebration of that, we're going to have a talk about space travel, or the future of space travel. And with us tonight, we have Ken Ruffin, who works with NASA. He's the president of the National Space Society of the DFW area. We have Dr. Wilder, who is a newish professor at UT Arlington. He is a space physicist. And we have Dr. Thomas Kupfer, who is at Texas Tech University, also a fairly new professor there, if I understand correctly. He is an astrophysicist. So before we get started, Ken will be giving the talk on the future of space travel. I want each of our guests to talk a little bit about the differences in their field so that we can understand the difference between if you're an engineer, if you are an astrophysicist, or a space physicist. What are even the differences? So let's go kind of in order of what's on the screen. So Rick, Dr. Wilder, would you mind telling us a little bit about what space physics is?
Yeah, so space physics is essentially the study of the space environment. So the sun and Earth's upper atmosphere, you can hear my dog running in, are both made of plasma. And the sun is constantly sending that plasma out through the solar system. It's called the solar wind, and that solar wind interacts with the Earth's magnetic field. It can interact with Mars and other bodies in the solar system, leading to all sorts of effects that can be harmful to technology, to astronauts. And so space physicist tries to understand the physics of that plasma in the solar wind as it interacts with various planetary bodies.
So Ken, would you tell us a little bit about the engineering side of why that's so important with the space travel in space?
Yes, absolutely. And thank you for that introduction, but I have to clarify just one thing. I am the chapter president for the award-winning Dallas-Fort Worth area chapter of the National Space Society, but I do not work for NASA. I am an engineer by trade, but not a NASA engineer. My original major was aerospace engineering, and that led me here tonight. So thank you for having me. Thank you for hosting Tap Talks. And, you know, I will, in this presentation tonight, discuss what NASA, well, actually, I'll give a little history lesson first, and then discuss what NASA's planning as far as travel to the moon, and how they will be working with companies. It's not going to be just all NASA activities the way it used to be historically. And then I'll discuss Mars and NASA's plans and other plans to get people to Mars and conclusions.
Thank you for that correction. I think this is actually a good opportunity to say that this was a terrible misconception on my part, but I think it's probably a common misconception that you can be involved in space and space travel and just be interested in space, and you don't have to work at NASA. And so I think this is a great, I apologize for making the mistake, but this is a misconception. And I think it's a good way to start out with, hey, you don't have to work at a university, you don't even have to work at NASA, and you can still be involved in this. And I'm sure Ken will go through a lot more detail on how you can be involved and how you can be interested and not have to work in the fields everybody knows about.
And Leslie, please don't feel bad. I have relatives that have said, hey, you know, I saw your post on Facebook, you know, you work for NASA. I'm like, no, I don't. but
I was an engineer before I was a physicist, and I had some family members who heard that and they go, oh, we need more mechanics in the family. So it's very common that our family doesn't all fully know what's quite going on, that's for sure. Mm-hmm. All right, Dr. Kupfer, would you mind telling us a little bit about astrophysics and the difference on that?
Sure, yeah, so first of all, thank you for inviting me and having me here today. So astrophysics is basically, we think about the physical processes and phenomena which are basically happening in the universe. And we basically cover all different kinds of fields. That can be from just understanding how our own sun and other suns evolve, basically are being born, evolve, or die. But it can also go as far as how really big stars evolve and die. But even beyond that, how galaxies evolve and how basically phenomena the entire universe goes, thinking about galaxies, thinking about black holes, thinking about all these different concepts. And they can teach us a lot about physics in very different aspects. So there's the very broad topic about phenomena happening in the universe on all different kinds of scales.
This is wonderful. So we should be able to answer questions on pretty much any direction you'll come at us about space travel. So in the comment section on YouTube, if you write any of your questions, you can also comment, have some chat in there. We will collect all the questions, and then after Ken's talk, we will go through and we will discuss the questions with all three of our panelists. So please feel free to put your questions in now or later. We will collect them and make sure we get back to them. So Ken, whenever you are ready, if you want to share your PowerPoint, you are welcome to start giving your presentation. And let's all learn about the future of spaceflight.
Oh, thank you very much. I am in the process of sharing. Bear with me. And you'll have to let me know if you can see my screen.
I will as soon as it shows up.
If you see the PowerPoint.
No. Does Ken seem to be frozen to y'all, or just to me? Did we lose?
Hang on a second.
Not a problem.
Okay. I know we went through this. We went through this during the trial run, and of course the options are different now.
So because this is Tap Talks, I do want to point out that scientists do like to drink as well. And so if any of you at home would like to grab a drink right now, this is a great time for it. We also have Thomas, who is a German, I believe, so he can definitely attest to scientists do love to drink. It's a beautiful way to participate in science and talk about science. And one of the things my boss told me once, if you can't talk about physics while you're drinking, you probably don't actually know your physics. So
Very true.
My boss is, if you can't tell, he's somewhere from Europe, like, based off that conversation.
Okay, so let me know if you can see my screen now. I mean, the presentation now, I should say.
No such luck, no.
Oh, wow. Okay. This is going to work.
We could have our tech guy hop on and talk with Ruffin for a minute if, Ben, you want to show your face and help out. But until then, let's see if any of y'all have anything fun to say in the chat for me to talk about. I like people talking about drinks. That's always a fun one. Oh, actually, Ken, you are sharing a screen. You're just sharing your team screen. See if you can share, or on that desktop, maybe show your PowerPoint. By the way, so those of you who don't have to take meetings all day long where you're having to share screens and stuff, this is absolutely normal. We deal with this all the time. That, and people forgetting to mute themselves when they go to the restroom, that one's always a fun one as well.
Oh, yeah. And I got it on the second try earlier today. You said share the desktop window. All right, let's try that.
First question from Zane Miller on our chat is, how my day is going? My day's going great.
Do you see my presentation now?
Not yet.
So you know the best part is when you have this super famous professor and is sharing its screen, and then instead of the actual presentation, like a background image popped up.
Oh, no, yeah. Or people still have their file manager open, and it's obviously their home computer, and they have a few too many things saved on there. Yes.
That happens all the time.
Absolutely. This is normal. Even the people who use Teams every day, I swear, at least once a week, we have someone who's the settings changed or something and the screen sharing is not working.
Okay.
Ben, do you have any suggestions? We can also, I just don't want to go over it. I can't. I like seeing the close up to my face. That never gets old.
Oh, we almost had it.
What was that? The option to share an application isn't coming up, unfortunately. It's only giving me the option to share my whole screen. Right. That's the only option that's coming up now. It obviously didn't work that way a couple of hours ago when I tried this, but every time I try now, that's the only option.
Would there be... Actually, Ben, you can't leave this team, can you? I was going to say, could you and Ken go in a different meeting? But if you do that, then I get kicked off YouTube, huh? Okay. Would it be helpful if Ken maybe logged out and logged back in and tried again? Did you log in somehow differently with Teams? Or you maybe signed in with your work account or something?
No, it's not through my work account. But I will log out and log back in. I apologize. And
this is perfectly normal.
Okay.
Not worries. I will talk with Thomas and Rick while we wait, while we just keep trying to figure it out. It's not a problem.
All right, I'll get back as soon as I can.
So Thomas, since you went last time, do you want to talk about a little what directly your research is?
Yeah.
Remembering in layman terms, none of us have an astrophysics degree.
Exactly. No, that's fine. Yeah, please always feel free to ask and then reach out if there's anything not entirely clear. So I particularly work with stars, and I particularly try to understand the evolution of stars. So to understand really what do stars end their life with. And I'm usually not looking at just single stars like our sun, because you might be surprised, but half of the stars in our galaxy actually have a companion star. So they're not alone. Like our sun has planets, but there's no companion star. But half of the stars in the galaxies have actually a companion star. And some of these stars actually have a companion star so close that they interact with the star. They can even merge, for example, with their companion star, make a single star or explode. And these kinds of events we try to find and see, and then try to understand what's happening to these stars, actually. So that's pretty much what I'm trying to understand is how these binary stars, which we call them, like these stars where you have two stars together, how they basically evolve, what they will happen in the future with them, and then exactly these kinds of processes.
That's pretty cool. So you don't just deal with the stars in like our galaxy, or is it throughout, I guess, of space?
So mostly in the Milky Way, just because the other stars in other galaxies are just too faint most of the time. It's really they are so far away that they are so faint that with our current technology we are not able to see them. Right, so we see the galaxies, but the individual stars in these galaxies are very hard to see. We really look at the stars. If you go out in the night and you're not living in the middle of a city, you see this very nice white band, which we get the Milky Way, and this is basically just millions and millions of stars. And this is exactly the region where we mostly look at.
Can see your PowerPoint. This is perfect.
Yes. Okay.
Rick, we will we'll get back to what you do for your research when we get to the panel, if that's okay.
Sure, that's fine. Yeah.
All right. So Ken, let's see if when you share, go into PowerPoint mode, if we can still see it full screen. Sure. And then we might actually be good to go.
Okay. Yeah. How about now? How about now?
No. It's okay. Maybe you can just zoom in on the PowerPoint itself, on the slide, and so instead of doing slideshow, you'll just have to individually click through each slide. Would that be?
There could just be lag. Did you do view slideshow?
Oh, wait a second. I think I know what I did wrong.
Okay, because we can definitely see your PowerPoint. We just don't see it full screen at the moment.
Oh, right. And okay. Now,
it's beautiful. It's perfect. Now, if you can just minimize my face in the right-hand corner.
Gotcha. Okay. Wow, that took That took almost as long as the presentation itself will take. Okay, thanks to everyone for their patience. I'm going to go really quickly. Time is certainly an issue now. So, again, I'm Ken Ruffin, president of the award-winning National Space Society of North Texas, here with DFW Tap Talks tonight for this World Space Week virtual event. And I'll talk about World Space Week in a moment. This is the Moon and Mars, the future of spaceflight. And this is up to date as of October 8th, 2020, yesterday. So I apologize if anything's outdated. All right, so table of contents, there'll be an introduction. I'll talk about the Moon and Mars, travel to and from, and conclusions. And no, this is not a science fiction presentation at all. I just want to make that clear in advance. All right, I mentioned World Space Week. It's celebrated from October 4th through October 10th of every year, and it's because on October 4th, 1957, that was the start of the space race when the Soviet Union launched the very first robotic satellite, the very first object into space, into Earth orbit, and that was Sputnik 1. Again, starting off the space race. Then on October 10th, 1967, that's when the United Nations signed the Outer Space Treaty. So the United Nations in 1999 declared that the 1 week period between October 4th and 10th is World Space Week every year. And on the worldspaceweek.org website, there's a list of hundreds of space events going on across the United States and around the world this week, and in particular today and tomorrow, being the start of the weekend. So several companies, you may have heard of companies building their own rockets, building their own spacecraft, and they've been making success. They've had successes, probably getting more attention than what NASA has gotten. So one of the things that I always try to stress with all of my presentations is that NASA is alive and well. People constantly talk about budget cuts and funding issues and this, that, and the other. That's simply just not the case. NASA has constantly been not only improving technologies, but also making discoveries with its robotic flyby missions and orbiters and landers and rovers in various locations throughout the solar system. And we'll talk about a few of those. So NASA's plans are as President John F. Kennedy said, but the last part of his phrase was not just to go to different locations, but to return them safely to the Earth. So with spaceflight, it's always been robotic missions going first, and robotic missions have gone to LEO, low Earth orbit, to the Moon, to Mars, to asteroids, and to all the planets, and even Pluto, the former planet. And the idea is send the robots first and then send people afterwards. So you'll see a little bit of a summary of the history of people going to, robots and people going to the Moon, and robots going to Mars, and we'll see what comes next. So this is a photograph of the full moon, and we've all seen the full moon. But how many of us, and I would imagine none of us, have seen the full moon from only 10,000 miles away? 10,000 miles sounds far, but the moon is 238,000 miles away. So this photo was taken by the first astronauts to actually land on the moon, the Apollo 11 mission, where Neil Armstrong and Buzz Aldrin, Dr. Buzz Aldrin, landed on the moon on July 20th, 1969. So this is an awesome photo from a distance where even in 1969, it's a really clear, sharp photo. All right, this is a table that I made based on some research, and this is as of October 3rd, still probably current to this day, showing the past of robotic and crewed meaning people, a crew of people going to the moon. The former Soviet Union, now Russia, has sent 20 robotic missions to the moon since 1959, none currently active. The United States has sent a total of 41 missions either to the moon or near the moon for a variety of reasons. Most were going directly to the moon. Some were flyby missions where Space Probe went near the moon and actually went either to another destination further away or came back towards the Earth. 32 robotic missions since 1964, 9 crewed missions. That was the Apollo program from 1968 to 1972, where 12 men walked on the moon, and there were 12 men who were near the moon, and 3 of the ones who were near the moon actually walked on the moon on a later mission. So actually 21 people total, not confusing. And 3 of the robotic missions are currently active. And you can see from Japan, ESA, that's the European Space Agency, China, India, and Luxembourg, all have had robotic missions to the moon. Okay, here's a photograph. I talked about Apollo 11, the first moon landing, where there were 2 guys who went to the moon, in the same lunar lander on July 20th, 1969. That was astronaut Neil Armstrong, who walked off the lander first, and Dr. Buzz Aldrin, who walked off next. Neil Armstrong took this photo of Dr. Buzz Aldrin. So whenever I give this presentation, I ask, can anyone see Dr. Buzz Aldrin's face in this picture? You probably can't tell because there's a reflection. You can actually see Neil Armstrong and the lunar lander. But, okay, here's a photo from 1969. Neil Armstrong on the left, Buzz Aldrin on the right, and in the center, that's Mike Collins. He stayed in the Apollo capsule orbiting the moon while the other 2 guys went down to the surface. So on the previous screen, I asked you if you could see Buzz Aldrin's face. It was a trick question. The answer was no, but you could see his face here from 1969 on the right-hand side of the screen. And this was Buzz Aldrin in 2019. So this is where I give my first shameless plug for the National Space Society. Through the National Space Society, I have had the opportunity to meet living legends such as Buzz Aldrin, Dr. Buzz Aldrin, the second man to walk on the moon, and many, many, many other astronauts, engineers, scientists, you name it. So, and executives with NASA and executives with the commercial spaceflight companies. So, just a plug for the National Space Society. All right. Let's talk about Mars. This is actually a composite photo with several small photos taken at different times and then stitched together from, from the Viking Orbiter 1 between 1976 and 1980. This was the Vikings were 2 orbiters, Orbiter 1 and Orbiter 2, and there were also 2 landers, Viking Lander 1, Viking Lander 2. That, again, arrived at Mars in 1976, known as the bicentennial anniversary of the United States. So, composite photo, many photos combined together, giving you a great view of Mars and what looks like a scar, perhaps, across what kind of looks like the center, like near the equator of Mars. That's Valles Marineris. That is the largest canyon in our solar system. If anyone has ever seen or been to the Grand Canyon here on Earth, Valles Marineris is several times longer, deeper, wider, you name it. So.
Can I interrupt? Was it probably caused by the same thing as the Grand Canyon, like some giant glacier? Do we know?
Interesting question. Whether it was caused by a glacier or water, I honestly haven't seen that level of detail. However, in the past, in Mars's past, according to scientists, you go back to about 3 billion years ago, there was an extensive amount of water covering Mars, particularly on its northern hemisphere. So it very well, I'm going to guess, very well could have been a glacier that carved what looks like a gash on the surface of Mars. But that was one of the forces at work. Glaciers, it's certainly cold enough then and now, and again, running water. So
sorry for interrupting. I just got excited.
No problem. No problem at all. It keeps me on my toes. All right. So I showed earlier a table of robotic and crewed missions to the moon. So far, we have not. There have not been any people going to Mars, but there have been. Oh, and I didn't point out, as far as those missions to the moon, excuse me, those were only the successful missions. I neglected to say that, even though it was on the screen. There were many unsuccessful missions, especially in the 1960s, when space travel was still new and there was still a significantly more risk than now. And that was the case for the United States and the Soviet Union at the start of the space race for the moon, as well as for Mars. And as you can see, USA, 17 successful robotic missions to Mars. 6 of them are still active. And Soviet Union, you see 6 successful missions. Now, what I don't have in writing here is if you're curious about the number of unsuccessful missions, it turns out the approximate number of successful missions for Russia is equal to the, I'm sorry, I said that wrong. The successful missions for Russia is almost equal to the unsuccessful missions for the USA. And the number of unsuccessful missions for the US, flip the numbers is what I'm trying to say. The USA successful missions are equal to or close to the unsuccessful missions for Russia, and the unsuccessful missions for Russia are, well, you get it. So, European Space Agency, 2 missions, India 1, UAE, United Arab Emirates, has a robotic probe currently en route to Mars, and so does China. And I didn't mention earlier with USA, the USA also, through NASA, has a probe en route to Mars. The Perseverance rover is en route. So that's a whole nother presentation. I actually have a presentation on Mars exploration, past, present, and future, where I go into lots of details about those. That won't happen at this time. Moving forward, I mentioned the Curiosity rover, the Mars Curiosity rover, because this gentleman, Bobak Ferdowsi, got the nickname Mohawk Guy back in 2012 when the Curiosity lander successfully completed its the Curiosity rover completed its entry, descent, and landing on Mars. He was in the room at NASA's Jet Propulsion Laboratory, JPL, and got lots of attention. He didn't fit the expectation of what you expect for NASA scientists and engineers to look like, but he's an aerospace engineer that I had the pleasure of meeting also in 2019 or 2018 at one of the annual conferences of the National Space Society. Yeah, that was 2018. And so was the photo with Dr. Aldrin. So in summary of my introduction, there have been, as you saw, dozens of robotic missions to the moon and Mars, as well as asteroids, and human missions to low Earth orbit. We're approaching as of this time the 20th anniversary of people continuously living and working in space in low Earth orbit on the International Space Station. And that's coming up, the 20th anniversary, on November 2nd. So with these robotic missions and human missions of the past, they're all laying the foundation for more exciting, more ambitious missions yet to come. All right, so let's talk about the moon. We're done with the intro. This was a photo from 1972 taken by astronaut John Young of the surface of the moon, and an instrument that was used that helped as a photographic reference for that, so the astronauts would know the angle of the sun, so on and so forth, to get the ideal lighting for photos that they took. All right, but let's move forward and talk about the Artemis program. For anyone who is wondering, what has NASA been working on? What has NASA been doing? Since they may or may not have seen NASA activities on the news or online or on social media, what have you, the Artemis plan was announced as, the name Artemis comes from the Greek. The Apollo program back in the late 60s and early 70s, Apollo was a Greek god, and the Apollo program was to get people to the moon. It was all men at that time. Well, in Greek mythology, Artemis is the sister of Apollo. So the idea with the Artemis plan or Artemis program is to have the first woman and the next man go to the moon and continue with missions building upon that. And the idea is not to repeat the Apollo missions, again, late 60s, early 70s, where astronauts went to an area basically near the equator of the moon. In this situation, with the Artemis program, astronauts are going to go to an area at or very close to the South Pole of the moon. And the South Pole is extremely interesting because, as you see in this image, they're in the craters at the South Pole. The sun never shines in those craters, and there is ice. There has been ice, frozen water, that's been confirmed, and we're expecting millions, if not billions, of tons of this ice. So having a source of ice, once it's melted, purified, if you have liquid water, that's obviously water to drink and everything else that we use water for. That's you can split water into its elements, hydrogen and oxygen, so you can have oxygen to breathe. That's important, and that's this. With water on the moon, you don't have to bring water and its components from Earth. So water to drink, and for watering plants, so on and so forth, bathing, everything else, oxygen to breathe. Then gaseous hydrogen and gaseous oxygen can be used in something called a fuel cell to generate electricity. And last but not least, one of the most efficient chemical fuels in existence for rockets is liquid hydrogen and liquid oxygen. So by having an access to millions, if not billions, of tons of water on the moon, again, we don't have to bring water to drink, oxygen to breathe, a source of electricity and rocket fuel from the Earth. So that's something that's an industry that we have to look forward to, and people will have an opportunity to be self-sustaining, at least to a large extent, because of ice on the moon. So Artemis, I pretty much talked about what Artemis is about. I said the first woman and the next man, and that's by the year 2024. And the idea is to continue, instead of just individual missions where astronauts go and come, do some experiments and come back, the idea is to build up infrastructure over time. And by the year 2028, just 4 years after the human return to the moon, the idea is the astronauts would have some degree of self-sufficiency, being able to survive, at least in part, on their own without constant resupplies from Earth. So this is a table showing a timeline at the top, 2021, next year, as of this recording. These will be new robotic missions going to the moon. Then that's the commercial lunar payload services. There will be several instruments there. And then Viper is really interesting. That's an acronym. It might be the coolest space acronym that I've ever heard of, and I'll discuss more about it shortly. Then more satellites, and then Artemis 1. That will be the mission without people, but using the rocket, the brand new rocket, and the new spacecraft that NASA's been working on literally since 2011. So 9 years as of this recording. And PPE and Halo, we'll talk about that. Artemis 2 and Artemis 3, I'll go into those as well. All right, so Viper, that is not a poisonous snake. That is the Volatiles Investigating Polar Exploration Rover. It's a robotic spacecraft that will travel around those craters in the South Pole, at the South Pole of the moon, drill into the surface, and over time, over 100 days, that's the expectation. So about 3 months, a little over 3 months, it will provide enough data to be able to generate a detailed map of exactly where the water is located in which craters and how much water. And this mission is scheduled for a little over 2 years from the time of this recording, December 2022. All right. I mentioned the new rocket. Planning started in 2011. And this is a computer graphics image of it. The majority of the rocket has been built. Testing has been ongoing with the individual parts. There's a major test coming up soon, and it is called the Space Launch System. It's abbreviated SLS. And at the top, it's hard to see in this image here, the capsule where astronauts would ride is Orion. So that is Orion to the right of your screen. That's the Orion capsule on the right, which is sort of cone-shaped. The service module is directly beneath it or to the left. And then further left is the ICPS, the Interim Cryogenic Propulsion Stage. And again, these have all been undergoing testing and more testing and more testing. And just looking forward to seeing it lift off. Now, this is a really busy slide. Short version. What this is saying is that Artemis 1 will be, you just saw the Space Launch System rocket and you saw the Orion capsule. It will launch from Earth. The rocket will launch from Earth, sending the capsule around the moon. It will make different orbits, as you can see. It's testing out. This is sort of, there's an old expression with cars or concerning cars called kicking the tires. If you're driving a car for the first time, a new car in particular, you want to see what it can do. I mean, you know what the paperwork says, what they said in the commercials and in the owner's manual. Well, this is NASA's opportunity to literally test everything out and see how things work. So, and this will be without people, but it's going to make complicated maneuvers before coming back to Earth. Then, with Artemis 2, the idea is, again, Space Launch System rocket, Orion capsule, this time with astronauts, but not traveling to the surface of the moon, but traveling what's called a free return trajectory to go around the moon and come back to Earth. Again, still testing out the new equipment with people on board. So that's Artemis 2. Now, what's being scheduled? I mentioned on one of those slides that listed several different things, like 7 different lunar, I guess, parts of the Artemis program. I mentioned PPE. That's the power and propulsion element. You got to have electricity, and you got to have rocket engines. And then Halo, the habitation and logistics outpost. That's the home and laboratory, home and workspace So on the really in the center of the screen here, you've got the PPE, power and propulsion element, and to the right, you've got Halo. So this will travel without people on it from the Earth to the moon, and it will orbit the moon. And this is the beginning, just these two sections, are the beginning of what's called the Gateway. And other modules, other sections will be coming afterwards. So with Artemis 3, this will be, it's scheduled for 2024, so 4 years from the time of this recording. The first woman and the next man by near the south pole of the moon, and again scheduled in 2024. Now, as far as getting to the surface, I talked about the rocket, and I talked about the capsule. I talked about the gateway, or at least the first two sections of the gateway. NASA, and this is a really interesting time. These are new images that I added to this presentation. NASA has sent out what's called a request for proposals, asking companies for ideas about landers. How do you get from NASA's plan from the orbit of the moon down to the surface of the moon and back? So option one is what's called the Human Landing System National Team. It's a few different companies working together. Those companies are led by Blue Origin. Now, some of you might be familiar with Blue Origin. Maybe most of you are not, but many of you may have heard about the owner or the founder of Blue Origin. It's this guy. His name is Jeff Bezos. He's the owner, founder of Amazon and Amazon Prime, and considered by most to be the richest person in the world. He also owns, as you can see in the background, that's Blue Origin on his New Shepard rocket. So if you can take a good look at Jeff Bezos's face and just kind of try to memorize it. Okay, now, and I know no one can respond, but I'm wondering who thinks that I'm talking to Jeff Bezos in this picture. That's me on the left, and you can only see the back of the gentleman's head here. So I'll keep going. Yeah, that was Jeff Bezos that I had a conversation with. And again, this was also during the annual conference of the National Space Society. This was in Los Angeles in 2018. That was a memorable conference, to say the least. All right. Another option for human landers is one being built by a company called Dynetics. And last but not least, the third option is literally being built by a company called Spacex, which also has a billionaire owner, a guy named Elon Musk, who might be more famous to most people for Tesla, but he's more famous to the space peeps and the space fam for SpaceX. He has been building and testing and launching test versions of the upper stage vehicle that you see here called Starship. What might not be easy to see, sort of near the bottom of the picture, not directly below the engines, but a little to your right, that's actually a person. So just to get an idea of the scale of just the upper stage of this rocket, this is not the entire rocket. This is the part of the rocket that sits on top of the part of the rocket that lifts off from the ground. But the idea is this will be, and I'll keep going, and you can see here that Starship is at the top of the rocket in this image. The part at the bottom is called Super Heavy. So together they're the Super Heavy Starship. The Super Heavy, together, I should say, this will be by far the largest, most powerful, most amazing rocket and spacecraft that have ever been built. This will dwarf even what has been the largest rocket that successfully operated since 1967, the Saturn V that took the astronauts to the moon and back. This will dwarf that rocket. This will have the capability of carrying 100 passengers at a time to the moon. So, NASA's plan, at least for the first trip to the moon, is for the first man and I'm sorry, first woman and the next man. Well, this could carry 100 astronauts or 100 passengers, or a combination of astronauts and passengers to the moon. It's absolutely mind-blowing. Here is the Starship, that upper portion, sitting on the moon, and it's hard to tell, perhaps, but near the center of the Starship, you see that it looks like there's a door that's open near the top, and then there's basically an elevator carrying some people down to the surface of the moon. So instead of 2 people or 4 people at a time, which has been NASA's plan, SpaceX says we can take 100 people to the moon and bring them back. Then Artemis 3 talked about that. So astronauts on the moon. This is one of many graphics that I've seen of what that might look like. And I talk about, you've seen just a couple of pictures of people I've met. On the right is the gentleman who is in charge of NASA, NASA Administrator Jim Bridenstine. So it was a pleasure meeting him in September of 2019. And I don't have a picture of the previous NASA administrator that I met, Charles Bolden. Maybe I should have squeezed in that as well. But again, thanks to the National Space Society, I've met some amazing people. So SpaceX, in addition to they're putting in a bid to have NASA's lunar lander, they're also separately planning what they're calling the Blue Moon mission. So lunar lander, NASA's planning to have people land on the moon starting in 2024. Well, the year before that, SpaceX has announced that there's a billionaire from Japan who has actually basically bought the spaceship. He will choose the people he wants to travel with him as they literally fly around the moon and come back in Starship, and that's being called Blue Moon. And this is the gentleman from Japan, and looking forward to that happening. On the bottom of the image is Elon Musk, the owner founder of SpaceX, and he actually was on stage, excuse me, at a conference a few years ago, where he had this image, on a big screen for a large audience to see. And this was a couple of years before NASA announced that they were that they wanted to work with companies to have companies send landers to the moon. Elon Musk and SpaceX were already thinking along those lines. So, as you can see, there are lots of detailed plans concerning the moon. Let's go forward to Mars. This is a photo taken by the MSL, the Mars Science Laboratory Curiosity rover, inside Gale Crater, looking at Mount Sharp off in the distance. So this photo was taken back in 2012, and Curiosity has already made its way not only to Mount Sharp, but is traveling up Mount Sharp, continuing its geology experiments, sending back lots of data. Now, as far as going to Mars, I'll talk about this in the order of when the missions were announced and when their schedules bring them to Mars. SpaceX, once again, this is the same image, the Super Heavy Starship. Super Heavy at the bottom, Starship at the top. The plan that SpaceX has is to have 100 paying passengers at a time traveling to Mars within the next few years. Not 40 years from now, but possibly 4 years from now. Possibly. We'll see. What you see here, this is that Super Heavy Starship. After the fuel is used up, most of the fuel is used up in the Super Heavy on the bottom left, that returns to Earth and lands, and it's it's expected to be reused and launched again. And then on the right, you see Starship on its way to, in this case, Mars, with 100 paying passengers. So the SpaceX plan is to have several starships, super heavy starships, launching to Mars at the same time. To get to Mars, there's something called a launch window where spacecraft or rockets can launch once every 26 months. It's a little over once every 2 years. So the idea is once every little over 2 years, send several of these starships to Mars at the same time, and over a relatively short amount of time, build up a settlement, build up a city on Mars with 100 people per rocket, but several rockets at a time. And that's what's being explained here. In addition to, I talked about using resources on the moon, using that water. Well, Mars also has ice, water ice, and the thin atmosphere of Mars is mostly carbon dioxide. And there are plans to use the water on Mars the same way you would on the moon, as well as using water and the atmosphere with robotic equipment to make fuel, or to produce fuel for the return trips to Earth. This is not science fiction. NASA also has plans. Again, I just mentioned SpaceX more recently announced planning to have people going to Mars in the year 2024. Prior to SpaceX announcement, NASA had announced getting people to Mars, astronauts to Mars and back in the late 2030s and 2040s, using the Space Launch System Block 2, and it's Block 1 that NASA's working on now. And one option, one possibility is a nuclear thermal rocket, nuclear thermal propulsion, which would cut the travel time from Earth to Mars in approximately half. So instead of about 8 months to get from Earth to Mars, it would take approximately 4 months. So that's an option. So this is an image of what it might look like with NASA's plan for the first humans on Mars. Now, keep in mind, SpaceX has, according to the SpaceX plan, there will be people on Mars at least 15 years sooner than NASA's plans. So I have a really strong feeling, the same way that NASA has this collaboration with companies now to get to the moon, it won't be long before there's something similar for NASA to get to Mars and get to Mars sooner. Now, people will need to eat. You can't bring all the food. I talked about water, and I talked about using separating water to get oxygen. Well, NASA has been testing ways to grow food, and this is a test of a greenhouse aboard a model of the International Space Station. So a variety of different vegetables being grown here. And in conclusion, as I just discussed, it's not NASA that's going to be responsible for everything. There are these companies, these amazing companies that already have significant plans. And in the case of SpaceX, they've already launched and landed and reused dozens of rockets, not the Super Heavy Starship, but the Falcon 9, a much smaller rocket than Super Heavy Starship, but still a large enough rocket. And this is my final slide. If you need more space information, especially if you're local to the Dallas-Fort Worth Metroplex in Texas in the USA, the National Space Society has virtual meetings on the second Sunday of every month. The next meeting just happens to be in 2 days, October 11th, but then also November 8th, December 13th, so on and so forth, beginning at 3:30 p.m. Central, 4:30 p.m. Eastern. Contact me, Ken Ruffin, president of the National Space Society of North Texas, for one virtual meeting invitation. And if you have any questions about joining to get information like this more regularly, the National Space Society and the award-winning National Space Society of North Texas, or any other chapter that might be in your local area if you're not in North Texas. That is my email address. I am on Facebook. The chapter has a Facebook account as well as Twitter. You're welcome to get in touch with me, with the chapter, through any of those options. And yeah, that photo that you see on your left, that's a photo taken from the orbit of Mars, from Mars's orbit, a photo of the Earth and the Moon. That's what it looks like, or that's what we look like, Earth and the Moon. This is home for us. This is what we look like from the orbit of Mars. And thank you very much.
That was fantastic. Thank you. We do have plenty of questions. Before we do, since you were mentioning that people can follow you on Facebook and find the National Space Society, for everybody watching, if you do enjoy our format that we have here, please consider liking and subscribing our video. It does help us so that other people can find us in the future who don't know us directly, where we can directly let you know some algorithm thing. So please like and subscribe. It greatly helps us. So we do have plenty of questions. Before we get to Thomas and Rick, if you don't mind, let's cover some of them that are very specific to the PowerPoint. So some of them, one of the ones, it was kind of close to the beginning. So in slide 10, if you don't mind going all the way back, you have a picture of Mars. And someone asked if you can see the Olympus moons in the picture. Are you able to go back, Ken, so that we can see that again?
I am. I was going to try to just jump back in one motion, but let's do it the old-fashioned way.
Sounds good. Old-fashioned works, right? That's what it's
Yes, it does. Okay. Slide 10. All right. Now, what was the question again?
Can you see the moons in there? I couldn't when I heard the question. I was looking, but I was wondering if maybe you were able to see the moons.
That's a great question. The short answer is no. I don't see the moons in this image, or in this, I'm sorry, this composite photo. I don't believe the moons are in this photo, but I do have, in my Mars exploration presentation, I do have photos, and of course, photos can be found at nasa.gov and NASA through social media. You can see detailed photos of Mars's two moons, Phobos and Deimos, and they're much smaller than Earth's moon. Earth's moon is about 2,100 miles in diameter, or 2,200 miles. It's about the distance of the continental United States from coast to coast, from the East Coast to the West Coast. That's Earth's moon, but Mars's moons, you're talking a couple of dozen miles each. So at the most, and so they're so very small. They're possibly captured asteroids, and there's actually a mission being planned which will determine, ideally, once and for all, whether or not they are captured asteroids. But no, I do not see them in this photo.
So I've been corrected. They weren't asking about the moons. They were asking about Olympus Mons. Is that a name of something?
Okay, Olympus Mons. On the,
I assumed it was
that is the largest volcano, not only on Mars but in our solar system, and I don't think it's in this particular photo. I'm trying to remember. In other photos, have I seen a relationship between where Olympus Mons is versus Valles Marineris? And I don't think I've ever seen both in the same picture. So even though there are what looks like three really large mountains on the left edge of the screen, or left edge of the composite image, I should say, my guess is none of them would be Olympus Mons, because there wouldn't be any other volcanoes that close to Olympus Mons. So,
okay.
Right.
So another one is kind of near the end. We don't need the slides, but what causes the 26-month window to be ideal to Mars? Like, that's a very specific window that has nothing to do with our weather or our season.
Yeah, it's an excellent question. It's because of how long it takes for not so much the the Earth to orbit the sun, which we know is 12 months or 1 year, but it's Mars. How long it takes for Mars to orbit the sun. Mars takes 26 months to orbit the sun one time. It's about 687 days, give or take. And it turns out that when Earth and Mars are in the margin of error of being at their closest, that is the ideal time to launch. Now, some of you may have heard that just in the last few days, I actually saw this on a local news station, that Earth and Mars were the closest that they've been in several years and closer than they're going to be until some year in the 2030s. Well, just a few months ago, there were 3, as I mentioned, robotic missions that launched on their way to Mars. So that they launched within the window before Earth and Mars were actually at their closest. And so they'll arrive, of course, a few months after this week, when, a few months after the time when they're at their closest, which is, from an astronomy standpoint, is called opposition. And but from a space travel standpoint, it's when Earth and Mars are at their closest.
Awesome. So Rick and Thomas, if you don't mind turning your mics on at any point, y'all can all start talking. I do believe one of the most, actually, I should tell you, Ken, we got some thank yous of people now realizing, trying to visualize the Mars geography and stuff. So that was very helpful. Thank you.
Anytime.
Okay, so we still have plenty of questions for your stuff, Ken, but I want to bring in the other two and start having everybody. So the question that was asking about magnetic field. Does Mars have a magnetic field? Does it kind of work like how we have a compass where we have the north and south? I expect, Rick, this is probably in your field. You're talking about how there are space weather and stuff.
So Mars has, at one point we think it had a magnetic field. And right now what they have is, there are remnants of the magnetic field that are caused by the metallic material in the crust that'll have these small magnetic loops. But it's not like Earth, where we have a massive magnetic field. And, that is one of the big challenges, is, the fact that Earth's magnetic field creates this sort of protective cocoon around us from the particles in the solar wind. And Mars doesn't really have that. And so that's part of why its atmosphere has been stripped away. And it's also a challenge for engineers to make sure, the stuff housing people is radiation hardened enough for them to survive. So.
Okay. So actually that just ran Earth, but because the magnetic pole is what makes our compasses work, right? This is actually not part of the question. It was just something that made me wonder. But so are we able to, so does that have to do with how we're positioned in the solar system, or does it have to do with our magnetic pole? Or are they related somehow? They're
roughly related. We have a dipole axis, which is so the Earth has a rotation axis, right? It's rotating. And its magnetic field, which is a dipole, it makes this sort of like bow shape as it comes out, has its own axis that's slightly tilted from the rotation axis. When we navigate on maps, we're actually using the rotation axis as our north and south pole. But when we have a compass, it's actually pointing towards the magnetic pole. And so, that's why, depending on where you are, that, you have to calibrate a bit. But yeah, north and south is both. And actually, some people argue that, the way our poles are oriented, it should be called the other way around. But, it's all just how you define your reference frame, right?
If I'd like to chime in on that, if I could, just and I certainly agree, with everything that you said, and that was an excellent description from a scientific standpoint. But from a space travel standpoint, now this is just my opinion. It's not something that I read, not something that anyone told me, but because looking ahead to when people are visiting Mars, living on Mars, whatever the case may be, in order to be able to travel and have and be comfortable, that you've got a accurate sense of direction, I think that there will be a Mars GPS. I think that there will be satellites orbiting Mars, similar to and probably a more advanced version of the GPS that we take for granted here, of a network of satellites, dozens of satellites, and not in low Earth orbit, not in geosynchronous Earth orbit, which is 22,300 miles altitude, but in between, in middle Earth orbit. So I think in middle Mars orbit, there will be a set of GPS, Mars GPS satellites, so that people won't get lost. You know, you got to be able to find that Starbucks on Mars and getting back to the other point, protection from radiation, whether it's habitats on the moon or habitats on Mars. My expectation is they will be underground. And by being underground, you have the protection not only from radiation, not only from the solar wind, but also from micrometeorites.
Okay, awesome. Thank you. So this question might be Cooper, if you don't mind. So what's responsible for Mars's red color? I think this is you because you do everything, but this might be for Wilder. But what makes Mars red, and why do all the different planets have different colors? We've got a whole little rainbow in our solar system.
So maybe somebody else is better to answer that, but I think it is because it's actually rust, what we see, right? It's the iron is basically just rusting, and that's the color what is causing it to be red. Maybe somebody else knows this better, but I think that's the reason.
Yeah, that's pretty much it. The dust, which covers the entire surface of Mars, has a large percentage of iron, and that iron, as you said, when iron combines with oxygen, it forms a chemical called iron oxide, and the common term for that is rust. And so Mars is covered in rust dust, and that's the reason for Mars's color. And as far as each of the other planets, planets and moons or satellites, whichever you prefer to call them, they have different colors because of the elements that are present, whether it's on the surface. If you're talking about the rocky inner planets, there are different elements that make up the majority composition of the surface. And with the gas giants in the outer solar system, Jupiter, Saturn, Uranus, Neptune, it's different gases, whether it's hydrogen, whether it's helium, whether it's ammonia, whether it's methane. You've got different gases and different compositions. So those lead to the rainbow colors that you see throughout our solar system.
Ken, actually, if you want to close out your PowerPoint so we can see everybody's faces a little more. A follow-up with that question is the iron content of the crust and of all of Mars, does that effectively magnetize the whole thing, causing that to be maybe why there's a magnetic field in Mars? I think this one's aimed at Rick again, going back to your question about the magnetic poles.
Could you repeat the question? Sorry.
Sorry. So we were just talking about how Mars is covered in the iron. Does that effectively magnetize Mars?
No, the magnetic fields that still exist on Mars are only confined to certain parts, and it's actually due to the metal in the crust of Mars. So there's different layers of
like iron's only at the top and not at the bottom.
Yeah, well, so I think the crust is basically carrying any magnetic field is essentially caused by an electric current somewhere, right? And so, the crustal fields are basically portions of Mars's crust that still, are ferromagnetic because they still have some remnant of current. Mars, once upon a time, they think actually had a core that was rotating liquid metal, which is how you really generate the big magnetic fields. So what little magnetic field we have are, basically crustal fields that have been excited and still generate some magnetic field, if that makes sense.
So.
And if I may, I don't want to just jump on every question. I agree once again. But we talked about the surface of Mars being covered in not in iron, but in iron oxide, which is rust. And rust is not magnetic. That's the thing. If it was, if there was solid iron, across the surface of Mars, then there would be a discussion about, there would be evidence of magnetism. But iron oxide dust, it's just dust. Like if anyone's been to West Texas or Western Oklahoma, it's a similar color.
Oh, that's true. It's not my state.
Yeah.
State that you're forced to go through to get everywhere else. In my opinion, no one attack me. I'm a Texas gal. It's all about Texas. So this next question, I'm going to divert a little bit. So I want to know, based off of each of your fields, what would you gain by us sending another rover to the moon and collecting more samples? Well, I'm going to ask all three of you, so try to think, would you have a benefit in your field, whether it be space science, engineering, or astrophysics? What would you benefit? So Ken, we can start with you. What do you think the benefit would be for sending another rover to the moon? What more could we study there?
Oh, wow. I'll make the answer short. NASA never did send any rovers to the moon. During the space race, the Soviet Union did send rovers to the moon, and the Soviet Union had robotic equipment or robotic probes to bring samples back from the moon. NASA's astronauts brought samples of lunar rocks and lunar dust from the moon. So with the plans that are in place to send rovers and other robotic equipment to the moon, I mean, I didn't go into the details, but except for Viper, I did say that it will go to the south pole of the moon and analyze the ice and the composition of the ice. And I didn't talk about there are other elements and compounds present besides just ice. So they're probably in trace amounts, but if there's ammonia, that's a source of nitrogen as well as hydrogen and other chemicals, then there are many chemicals that can be put to good use. We just have to know where they are, how much of those chemicals there are, and then that's less material that has to be brought from the Earth to the moon. If we can process things there. So the more we can learn from the robotic equipment, the easier things will be for the people that will be living there or even visiting.
Okay, thank you. Thomas, would you have any advantage in astrophysics for having a rover on the moon?
Absolutely. So we have an atmosphere on Earth, which is good for us because we can breathe, and it also protects us from high energy particles or high energy radiation like X-ray or UV radiation. So, right, it's really like a protective layer above us, but it also prevents us to observe the sky in exactly these high energy wavelengths. So if you want to know how a star or a galaxy looks in X-rays, we cannot do this from Earth. We have to go into space, and we have, for example, spacecraft to exactly do that. But if we, for example, being able to put a telescope on the moon, then we can actually really localize this telescope and don't have to be a spacecraft, but really have a telescope on the moon. And actually, in fact, the European Space Agency is planning to send also a probe to the South Pole, or close to the South Pole, and they had a call for ideas what this probe can bring to the moon for some kind of scientific equipment. And one of the ideas is actually bring a small telescope which fully robotically operates on the moon, which observes in X-rays or UV, ultraviolet bands, which are inaccessible from the Earth, but nicely available from the moon. So absolutely.
I do have a follow-up question, but before I come up with that, Rick, would you mind saying for space physics, what would having a rover or a base on the moon give for you?
So, well, first of all, if you're going more of the surface stuff, to line up with what Ken was talking about earlier with, when we landed people, we were only landing on the equator. And, there's only been a few rovers that have collected samples. And One thing that scientists, whether they're geologists or meteorologists or space scientists, always want is more coverage. And so just having samples from more places and exploring more regions is good. As far as, the space environment, having spacecraft orbit the moon is valuable. Right now, we actually have a mission. It's called Artemis. It's also NASA, and it has nothing to do with the Artemis that Ken was talking about. That actually is loaded with plasma instruments that orbits the moon. So it gets to see how the moon sort of interacts with the solar wind, as well as when the moon swings back behind the Earth, how it interacts in the Earth's magnetosphere. And so that can tell us more of what we might expect when we send spacecraft to other unmagnetized planets like Venus or Mars, as well as, if you go further out, there are a lot of moons of Jupiter and Saturn, some of which could even sustain life. Some have liquid oceans under an ice surface and whatnot. So.
Okay. Well, I also have a follow-up with you, but I want to go back. This is great. This is covering a lot of topics. So actually, let's just go back to Thomas, if you don't mind. Oh, I remember. It's the telescopes. So do astrophysicists use more ground-based telescopes or space-based telescopes?
It entirely depends on what you're actually most interested in. So it's really a difference. So for example, I mostly use ground-based telescopes, but there's a whole other group of people who usually use X-ray telescopes, which are entirely in space, because there's no way of observing X-rays from galaxy from the ground. So it's actually we do both, but obviously ground-based telescopes being built is usually much cheaper than sending a spacecraft, which has as a telescope. So most of the astrophysicists, I would say, use ground-based facilities just because they're more accessible and there are more of them available. But they're very different fields because you cover very different physical phenomena, looking at very different energy bands. So
there's also a follow-up. I'm going to need y'all to tell me what this is, but people asked for both Rick and Thomas of the James Webb Space Telescope. Would it be useful in y'all's work? And first off, though, can someone tell me what the James Webb Space Telescope is?
I think that's a Thomas one, yeah.
Yeah, so people might have heard the Hubble Space Telescope, which has been in orbit now for 30 years. I think this year, 30 years. So it has produced, if you look at all these really pretty amazing pictures of galaxies and nebulae, and most of them were taken with the Hubble Space Telescope, but it's already 30 years old. And so it's coming into an age where you slowly think about, well, it may retire. So the next generation of these really big space telescopes is called the James Webb Space Telescope. And that's a telescope which Hubble has a diameter of the mirror of 2 meters or 2.5 meters, whereas the James Webb Telescope, I think it's 6 meters. So it's much bigger. It's a much bigger mirror, so you can look at much deeper into the universe. It's much further back in time in the universe. So it's a space telescope which is actually a little bit delayed, but it's supposed to be launched hopefully next year.
I know that everybody's schedules are a little bit off, which, Ken, that's a question for you too in a second for schedules. Oh, please go ahead, Ken.
Yeah, I again agree with everything he said. Now, one of the other differences between Hubble and James Webb is that Hubble looked at visible light. As he described, the image, or I should say the photo that's behind you, is probably, I'm guessing, from the Hubble Space Telescope. But James Webb will not be looking at visible light, but it will look at infrared radiation. So it will, as he explained, be able to see a further distance, an even further distance into the universe, which is the same as seeing further back in time. But it will, I should say also, because it's looking at infrared wavelengths, it's going to see things, not only the objects that we know that exist, but this is, again, just my opinion. My prediction is that we will discover at least one new something in space that we currently don't even know exists, because we can't see it. We can't see it physically, or I should say literally, with our eyes, and or even with the instruments that we currently have on Earth and in space. But James Webb Space Telescope is so much more advanced that I believe there will be breathtaking new discoveries that will just blow everybody's minds, and everybody can just fall out their chair all at the same time, all over the world.
I
And I'm looking forward to it.
Pictures. Everyone already loves the pictures coming from the Hubble telescope, right? It'd be
Let me
great.
just
Oh yeah.
This is, I think, one of the beauties in astrophysics. Even whenever you build a new instrument, a new telescope, it's actually almost always the case that you find something which you did not expect to see, which is one of the beauties, I think.
Yeah.
So, Brick, space physics, I know you were talking about weather and all. Can you even use a telescope for yours? I know it's not an insult by not using a telescope.
Oh, no,
Like,
so with the big joke Dr. Ramon Lopez, who's the head of our space physics group at UT Arlington, always likes to make is the difference between space physics and astrophysics. Is space physics is mostly studying the stuff that we can feasibly fly to. And so you don't necessarily need a more powerful space scope. What we really need is more, we tend to use more radio instruments and robotic instruments to study what we're doing. We want to fly probes in the middle of what we're looking at. It's so the James Webb looks like, I think it'll be fascinating once it's up, but we probably won't use it much in my particular line of research.
Gotcha. It's also nice to know the differences on that. So I'm going to go back to talking about rockets and maybe get in the middle of things. So why can't we reuse the whole point of your talk, Ken, right, is like we have all these rockets and now we're going in, we have reusable rockets. But why can't we use the rockets that are already coming back? The ones that don't explode, that aren't catastrophic, our rocket comes back, it lands, our astronauts get off, right? So why can't we reuse those?
We do. If it's a rocket, just if I understand the question correctly, if it in a rare situation where you've had SpaceX rockets launch and then land, the whole idea before SpaceX ever built any rockets was to launch, land, and do minor maintenance and then relaunch them. What the questioner might be thinking about is capsules and not rockets, because historically what NASA has always done, is to use what's called expendable rockets. These were rockets designed to be used one time to launch, whether it's a satellite into space, whether it's a probe going to Mars, whether it's the Hubble space, different with Hubble because that was on the shuttle. But when James Webb launches, that will be on an expendable rocket, not a NASA rocket, but a European Space Agency rocket. So I'm not sure if the questioner really meant rockets or if they or capsules, but the only rockets that I'm sorry.
So we all assume, at least as children, that you have the rocket ship going up, but the rocket ship is the part that gets you out of the atmosphere, and then you have the capsule that's holding the people inside. And so the new rocket you were talking about, I know I'm using the phrase wrong here, but you have the reusable rocket, I believe, that has 100 people in it.
The super heavy Starship being built by SpaceX.
Okay, so a Starship is actually not considered a rocket, just for technicalities for stuff. Is that correct, or would it? It
actually is going to be in its own category. Okay. It's not a capsule. It's definitely not a capsule. It's we and that's why I call it the Starship. It's like it's an advancement above and beyond anything that, to my knowledge, anyone else ever not only built but even discussed building. And I don't know, that's debatable. There were some plans, if you go all the way back to the 1960s, but there were times when different plans were discussed, but the technology didn't exist to make it happen. But now that the technology exists, SpaceX is making it happen. And also, I didn't mention in detail Blue Origin. They also have a reusable rocket. So far, it's just suborbital. But to make a long story short, historically, rockets were never intended to be reused. SpaceX started a revolution in space travel where rockets were intended. Rockets, I'll just say spacecraft, are intended to be launched, landed, and reused over and over again.
Okay. I think that actually answers, and I'm going to still ask the question just in case, because I know I'm not as good with all the terminology. But does that answer also what are some of the benefits of the new launch system over the old space shuttles? I feel like it does.
I didn't mention that during my presentation, and I really should have. The main advantage in reusable rocket technology is bringing the cost way down. You know, what pretty much everyone around the world has just taken for granted for decades is that space travel is just extremely expensive. You know, that's the way it is. That's the way it's always been. And the school of thought was, well, it'll go down eventually. You know, when I was a young student, you know, reading about space travel, there were plans where it would go down eventually. Well, it's going down now. And the idea is, by reusing the rocket, it's along the lines of if people are, whether you're driving your car, whether you take a flight, well, in particular taking a flight, you don't fly an airplane one time and throw it away. You know, you refuel it, do a little maintenance, keep flying. Well, with SpaceX and Blue Origin, the idea is the same. So that brings the costs down, and the cost will continue dropping. It's going to be mind-blowing in a very, very short amount of time.
That's actually really fun. So this is a question we have to ask of all of you. Do you all believe there are aliens out there? And we'll just do this around the thing. Ken, we'll start with you again. Do you believe there's aliens out there?
I'll answer quickly in two parts. Do I believe there have been aliens coming to Earth? You know, whether it's little green men, so on and so forth, from science fiction, I would say no. If there was intelligent life in the solar system, in our solar system, capable of space travel, we would have found them with the robotic probes that we have sent on and on and on to various locations. Now, that's the first part of my answer. Do I believe that there's intelligent life somewhere in the universe or even somewhere in our galaxy? Probably so. I just don't believe they're in, you know, flying saucers or in Area 51 or anything like that.
Okay. Thomas, how about you? Do you believe that there are aliens out there?
Well, first of all, as a scientist, belief is something, right? So we try to measure it or see it. And so we have not seen it, obviously, at this point. But if you think about just the number of planets out there in the galaxy, it's just mind-blowing. I mean, there are more stars than sand on Earth. And just if only some of them have planets. So there's a very large number of planets out there who potentially could have something which we on Earth would call life. That doesn't have to be intelligent life, but just something which we would call life in whatever way that might be. I think the probability is pretty high just because the numbers are so high. But also, even if there is intelligent life, well, the next star, the closest star to us, if you send a message by light, it takes more than 4 years to go there. And then another 4 years to come back. So really communicating with them, even if they are possible to do that, well, that's probably hard. So, yeah.
How about you, Rick? You seem very amused by this question, so I definitely want your response.
Oh, no, it's actually just funny because, you know, half the time when I tell people what I do, you know, at the bar or something, that's one of the first questions people ask. So, no, so, you know, I think I'm going to echo what everyone else has already said. You know, I haven't really seen the evidence of people, you know, coming and visiting here. Now, as everyone else has also said, the universe is just so huge. I would be very surprised if somewhere out there's not intelligent life. Now, as far as non-intelligent life, I think it might be more likely than sometimes we even think. I want to go back to the moons of Jupiter and Saturn. Europa. Recently, some of the spacecraft, the spacecraft of Jupiter have seen these plumes of water being blasted out of Europa. And so there's evidence that there is this liquid ocean under the surface of the ice on the planet. Now, that might not house, mermaids and mermen or something. It might just be single-celled organisms or what have you. But, I think it's worth even exploring for life in our own solar system if we can.
Mm-hmm.
And thinking about this, when we think about where life on Earth exists, where a human being would be dead within a second or 10 seconds, right? There we see microbes, we see bacteria in like the worst environments you can think of on Earth. So why would it? I think it would be very naive to think, why couldn't there be like this very simple life somewhere on the moon around Jupiter?
Yeah, exactly. Yeah.
Absolutely. And just to chime in, I completely agree. Whether it's microscopic, single-cell life, or maybe even more complicated life. Moons of Jupiter, moons of Saturn, at least one moon of Neptune. There are several different possibilities. And something that I've heard about recently, and it's actually a little awkward, there's a possibility that there's liquid water under the surface of Mars, at least in some places. And so if there's liquid water even there's a possibility of life under the surface. So, it's possible. I hope we don't find out the hard way. that somebody, something's there that says the equivalent of, hey, what are you guys doing? You're trespassing. We don't want that. But that's why, getting back to an earlier question about, I think the question was about rovers, but I think in terms of robotic missions, that's why we have to send these robotic missions out, whether it's exploring the universe, exploring our galaxy, exploring our solar system, or exploring under the surface of the moon or under the surface of Mars. Let's send the robots first, because worst case scenario, if somebody or something is there and gets upset, let it take it out on a robot and not on an astronaut or a settler, that just put up their home sweet home sign.
Yeah, and so to add to that, adding to the whole NASA's still up to things theme, one of the things coming down NASA's pipeline is a Europa Clipper that's going to fly really close to Jupiter's moon Europa, and so we might learn more about the possibility of what's going on under the surface through that. So,
yeah.
So we actually have a follow-up question. We have plenty more, but I want to do this follow-up. So there was the recent paper about the upper atmosphere of Venus and the recent biomarkers there. How do y'all feel about that being a possibility if maybe there's already life on Mars?
I have an opinion that that may not be very well received. I find it on the surface, I find it really interesting that there's potential biomarkers, potential chemicals that could possibly come from life. Just to explain what biomarkers are, could come from life, or they could come from, natural processes, could come from geologic processes. Whenever I think about the upper atmosphere of Venus, because I've heard of a few different possibilities, I've heard about, hey, you could have something along the lines of, think of the Goodyear blimp. You could have I'm not sure exactly how to pronounce the word, dirigible or something really close to that. You could have something that would float in the upper atmosphere. But the first thing that comes to my mind is, what happens if there's a mechanical problem and it's no longer floating? On the surface of Venus, it's about 870 degrees Fahrenheit in the daytime. And at nighttime, it's 870 degrees Fahrenheit. all the time, all over the surface of Venus. The atmosphere is 90 times thicker or more dense than Earth's atmosphere. It rains sulfuric acid, which means there would be sulfuric acid in the clouds of the atmosphere. I'm not going.
Yeah, I was going to chime in. It would be really interesting to explore robotically, but if there's something that's able to survive on Venus, I'm not sure I want to meet it.
That's hilarious.
But what did they actually see, right? They found a molecule in Venus, which, when you see it on Earth, it's usually produced by a bacteria, right? And the amount they found in Venus is very hard to explain with natural processes. So on Earth, as a comparison, usually that's done by bacteria. Whether there are bacteria, and they found it in the atmosphere, so that's really high up. It's basically a floating thing if it would be there. So whether there are bacteria or some microbes which produce this element or this molecule, yes or no, if it's a natural thing on Venus, I don't know. I think this result just shows us we should actually go there and have a look. So Venus was actually one of these planets which has been, a little bit, hasn't paid too much attention to.
Neglected almost.
Yeah, exactly, almost being neglected. So I think it's just a nice way of saying, hey, we should really go there and explore this atmosphere and see what we find there, what kind of molecules, and maybe we find microbes. If there's some life form, it's for sure not more than a bacteria.
I would agree.
Right. Yeah, but bad bacteria.
But it was by Hotshotter, maybe. So I'm just going to read the comment. I thought it was really good, and it goes with it. I believe alien travel would be easiest done when it's lighter and smaller, so the microscopic intelligent life could be here, and the size difference make it so small it's not interacting with us. So y'all are saying that, these would be microscopic creatures, I guess. Do you think it would be able to be intelligent at that scale? I know y'all aren't biologists, so this might be one of those things like this is so left field, but it was such an interesting question.
I guess it's very speculative. I mean, life can have whatever form they might have. I mean, a human has a brain to think, right? So a microbe has not this potential to think because it doesn't have the size to be. So, and I think but as I say, I'm not a biologist, and we see life in very different forms on Earth. But I think it's very hard to imagine that something which is as small as bacteria has the potential to think and make logical decisions on a way we humans do that, or very intelligent, what we would call intelligent life does it. Yeah, but it's a personal opinion rather than a scientific statement.
So this is causing some very interesting conversations. So I'm just going to keep adding some of these. I'll try to get to the last questions before we end at 9. But so we keep talking about, well, maybe these small ones are intelligent, maybe they're doing it, but couldn't they also, this is from Dan Levine, couldn't they also be dangerous without just not liking us? And I think that's, personally, I would say, yeah, it seems like, yeah, they could be dangerous just because viruses are dangerous, right? I don't think it's personal.
Yeah. That would be my biggest worry about finding a single-celled organism on another planet is, finding out too late that it could be potentially infectious.
Wait, space COVID is the last comment that I think.
I was going to say, the world is getting some experience, with a virus right now, and imagine if it was as described earlier, a virus that could survive on Venus, and then if it came to Earth. I had never planned to want to go to Mars or the moon or anything like that. But if there's some virus on Venus, and if it were to somehow come to Earth, I would go to another planet. I'd go to the moon. I'd go to Mars. I'd be out of here. Elon Musk, sign me up. Let's go.
Are there precautions taken whenever we have the astronauts that went and walked on the moon, and eventually they're going to walk on Mars, and hopefully they also eventually come back? Do we take precautions to clean off anything that would have been on their shoes, etc.?
May I? NASA has an office called, and there was a person hired for a new position just a couple of years ago, the Office of Planetary Protection. And it's about, the short version is it's minimizing the likelihood from what's scientifically practical of anyone or anything from the Earth bringing bacteria or viruses somewhere else, any other destination off the Earth, and the reverse. So it's protecting the other worlds, and it's also protecting Earth from anything that would come from the moon, anything coming from Mars, so on and so forth. So NASA has always put an extreme amount of emphasis on that. But in the last couple of years, because we're looking at a larger number of people going to the moon and going to Mars, there's an even greater emphasis beyond what there used to be. So yeah, from the beginning, I mean, from the first probes going into Earth orbit, going to the moon, and so on and so forth, that's always been a high priority. It's protecting Earth as well as protecting destinations in space.
That's the coolest office ever, by the way. Planetary or whatever you said. I love it.
Mm-hmm.
So I'm going to try to get to a few more questions before we get to the end. So I think this one is probably for Thomas, because you did talk about you work with stars and binary stars, which I believe is where you have two stars that can rotate with each other. So the question is it possible for planetary systems, kind of like our solar system, to form around the binary stars?
Absolutely. Actually has been. So you maybe know the Star Wars movie where you see Luke Skywalker walking on Tatooine, where you see the two suns rising behind Luke Skywalker. It's a very famous picture in the Star Wars movies, which actually is exactly in this movie a planet around two suns. And by that time, it was purely fictional. But nowadays, we actually know not a lot of them, but we know examples of planets that have been detected where a planet is orbiting around where there are two suns in the binary star. So yes, absolutely. None of these known planets are in an area where life would be liquid. Where water would be liquid. So we wouldn't call them as a potential planet with life. But yes, these planets exist and they have been discovered. Not a lot of them, but they exist, yeah.
So how normal is our sun compared to the other star systems?
That's a good question, because that's something we actually really don't really know. So for example, Jupiter is relatively far away. Most of the which we call exoplanets, where are planets around other suns, which we call exoplanets, are what we call hot Jupiters. These are Jupiter-sized planets, but they are so close to their host star that they're actually really hot. They're really heated up. So they're more like where Mercury and Venus is now a Jupiter-like planet. That is probably just a detection bias in that sense, because they're easier to see if they're closer to their host star, and that might not be the normal. But so far, something which looks like exactly our solar system, where we have rocky planets in the inner part and then gas planets in the outer part, there are not a lot of other examples. We have detected 4,000 exoplanets by now, right? Really a large number of exoplanets. But you'd be surprised how unique each of those systems is on its own.
Is an exoplanet everything outside of Pluto, by the way? Or every planet? I get not Pluto, because Pluto is not a planet, but like outside of that range, what defines?
So what we call exoplanet is actually a planet which is orbiting a star which is not the sun.
Okay. So it's not just a thing out there; it has to be orbiting a star. Is it also orbiting binary star? Just somehow there is a star.
Exactly. Yeah.
So if I can chime in on that, Pluto is actually part of something called the Kuiper Belt. It's a bunch of large, icy, planet-like and asteroid-like objects that are at the edge of our solar system.
Oh, so our solar system?
What?
Yep.
It does count. Okay, as long as you're not only taking away its planetary system like status, but saying it's not even in our solar system. Okay, it is in our.
But it's considered a Kuiper Belt object now. I mean, some of these terms are arbitrary. But you know, so you know, there are some things that are as big as Pluto out there in the Kuiper belts, and we don't call them exoplanets because they're still orbiting our sun.
Okay.
Yeah.
That's one of the reasons why Pluto is not a planet anymore, because our kids would have to learn in a few years from now 50 different planets. If we tell everything which has Pluto, we could call it a planet. So that's why it's not the main reason, but I think to make life easier, we call it actually a dwarf planet.
Yeah, NASA's New Horizons, it flew by Pluto, is now actually going out and exploring other Kuiper belt objects now. So we'll see some pictures from those soon, hopefully.
That'll be really cool.
Yeah, there are already pictures available from, of course, Pluto. That was July of 2015, and the second Kuiper belt object, which has been nicknamed Arrokoth. There are already pictures. Unfortunately, It didn't make a lot of news. It wasn't covered much on the national news, but that's already happened, and it's still, I think NASA's in the process of determining what the third object will be that it will study on its flyby. If I may, I wanted to get back really quickly to that binary star system, and it's not too often I can comment about stars. The closest solar system to our sun, when I was a kid, I heard it was called Alpha Centauri. But from then till now, we realized that there's not just two stars in that solar system, there are three. There's a binary star system, Alpha Centauri A and B, that orbit each other. And then there's Proxima Centauri, a red dwarf, which orbits the two binary stars. And to make things even wilder, there's at least one planet that we know of that orbits Proxima Centauri. So in the nearest solar system to ours, if hypothetically, if you or a robotic probe were on that planet orbiting Proxima Centauri, which is named Proxima Centauri B, you would be able to see the red dwarf in the sky at some point, and also Alpha Centauri A and B. You'd be able to see two sun-like stars, basically, and then the red dwarf. 3 stars in your sky at some point.
Yeah.
Really cool. So my next questions are going to be from nowhere because I do want to cover them. So one of them, we're going back to Mars now. And the question is, and I believe this one will be for you, Rick, does Mars have any interesting weather? And do companies have any plans of making solar wind a thing for money? We like wind power. Can we do anything with solar wind?
Well, so as far as weather on Mars, I actually don't really know much about weather as much as I do space weather, which is a little bit different. There are auroras on Mars, which is kind of neat. As far as how we could use the solar wind, there are ideas of using making solar sails, where you can actually use sort of the pressure from the solar wind, as a form of propulsion. I don't know if there are any companies doing anything like that, but
if I may, the atmosphere of Mars, and I probably didn't mention this, it's only about 1% the thickness of Earth's atmosphere at sea level. So it's like being on Earth at, I forgot exactly how many feet, but over 100,000, maybe 160,000 feet altitude. So the atmosphere is extremely thin. So if the question is about using like wind turbines to generate electricity, I think maybe that's what the person was asking. I'm not sure. But if that's the idea, that's probably not going to happen. There aren't powerful windstorms like in the movie The Martian. Spoiler alert, if you didn't see it, cover your ears. There's a windstorm near the beginning of the movie that was, really dangerous, but that was science fiction. That's not, even though there are sandstorms on Mars, but it's not the powerful Hollywood special effects like what you saw in the movie.
So one of my last questions is, actually I have 2 for you if you don't mind. First one is, so NASA's SLS launch system is not going to be reusable. So why are they building them? We're going towards reusable stuff. Why are we even bothering with the SLS launch system?
It's a matter of timing. In 2011, and I think I did mention the date. In 2011, the U.S. Congress created the NASA. I'm sorry, I said it wrong. In 2010, NASA created. Let me slow down. 2010, the U.S. Congress created the NASA Authorization Act of 2010. In that act, it was put in writing that NASA must use existing technology, and the companies that basically built the space shuttle, they must use those companies and those technologies and upgrade them to create the Space Launch System. So I could go on and on about that, but I promise you I won't. Even if we had the time, I wouldn't do it. But that's the reason. That's the short answer. It was political. So that's one thing. It was political, and it's still in writing. It's still there. That this is what must happen. And then SpaceX, even though they were talking about their reusable rockets at that time, they hadn't, they launched and landed their first rocket in 2010, that same year. Now they've done it dozens of times. So even though they had done it once that year, nobody knew if it was a 1 in a million thing, or if it was going to be the first of many, and that it was going to become normal. So it's a matter of timing and perspective. And this is the way it is.
Please go ahead.
I just thought of one other thing, and I'm sorry. Really quickly, the current NASA administrator that you saw me in a picture with, and the previous NASA administrator, when I met them, they were asked, what if, whether it's SpaceX or some other company, comes up with something that's bigger, better, cheaper than the Space Launch System? Guess what? Like Super Heavy Starship. What would NASA do? And each gentleman said, if and when that happens, they would retire, once that technology is proven, they would retire the Space Launch System. So, 2012 was when the previous NASA administrator made that statement, and I was in the room when he made it. So we'll see. We'll just have to see what happens.
All right. So, Thomas, really quick. So why do people study exoplanets? Is it looking for life? Is it looking for things that are going to be good for aliens?
I think it depends on the person himself. I think most of the exoplanet people do not do it because they think we will live there at one point. I think it's more out to understand if our solar system is something which is out there a lot of times, if it's something which is very common, or if it's really a unique set of how planets form. So I think the studying exoplanet is really mostly about to study and understand if something like our solar system is a common thing or is it not, and also to see how many planets there are out there. Obviously, we hope, and for example, with James Webb, we will be able to do that. We will be able to observe and study the atmospheres of exoplanets. So we will be able to see what elements, what molecules, at least some of these exoplanets have. And then again, we can look for biomarkers and see, is there ozone? Is there elements, molecules which are typical on Earth, which is typical for life? So that's out of curiosity, but I don't think it is necessarily to say, oh, let's go, this is a planet where we will be living in whatever time. I think that's a good side effect, but I don't think that's the main reason to do that for most of the people. Yeah.
So there are actually more questions that I'm not going to ask. We are trying to keep this at 2 hours, so I appreciate all the participation. There are more questions, but I am going to skip them. But I am going to ask one that during your talk, Ken, it got a lot of buzz on the chat, and so I've got to ask it. Just how much did you fanboy whenever you met Buzz Aldrin?
The first time that I met him, I met him 8 times. I have literally met him 8 times. I've met him at 6 different National Space Society annual conferences. He's on the board of governors of the National Space Society, and even though he's literally 90 years old this year, he has been a regular at those conferences. So 6 times at conferences, twice when he came to the Dallas-Fort Worth Metroplex. The first time I was nervous, didn't know what to say. But that last time, the one, that picture that I showed, when I walked up to him, I said, Dr. Aldred, I said, I know you've met millions of people. You probably don't remember me. And his response, he cut me off and said, "You're from Texas."
Oh my God, that's amazing. That's
And
really
I crossed my arms and I said, "Yes, I am." So that was, you know, I could have left the conference and just went home after that moment. But yeah, fanboy still, even though it's been 8 times, and hopefully I'll continue to see him again. Our next conference is in LA in May in 2021. Hopefully he'll be there.
That is really cool. All right, thank you all 3 of you. Ken from the National Space Society, we have Thomas from Texas Tech University, and Frederick from University of Texas at Arlington. We really do appreciate everybody coming to our live virtual events. Eventually, whenever things are back at normal, if you're in DFW, we will go back to breweries, but until then, we're going to be virtual. And speaking of other events, in 2 weeks, we are going to have another event, and it is going to be done by a student from one of the Nobel Prize winners. If you heard, the 4th lady ever to get a Nobel Prize in physics just won it, and one of her students is willing to talk, as well as we will have another lady from Harvard join as well. And they're going to be talking a little bit more about the supermassive black holes that just won the Nobel Prize. So if you're interested in that, please hit subscribe, or you can follow us on any of our social medias, whether it be Facebook, Twitter, or Instagram, in order to get up to date on that. Most likely it'll be on the 23rd at 7 p.m., same format, where it'll be live on YouTube. So again, thank you everyone for coming, and hope to see you again in 2 weeks.
Thank you, everyone.
Bye, everyone.
Thank you.